The James Webb Telescope has provided the clearest image of Proxima B in history, uncovering stunning revelations concerning this potentially habitable exoplanet. Join us as we embark on an endeavor through space to uncover the secrets of Proxima B and check if it might be the next Earth. We set off into the vast expanse of space where a fascinating planet exists in the habitable zone of its star, Proxima Centauri. This planet is not just any typical rock. It's Earth's cousin. Proxima B, located 4.2 light-years from us, is shrouded in mystery and wonder. Could it one day be another Earth, with oceans and life flowing across its surface? But wait, there's more. Proxima B isn't alone in its orbit around the red dwarf star. It has a lone companion, Proxima Centauri SE, which could reveal even more secrets the star system holds. Perhaps there's another companion we haven't discovered yet. The mystery doesn't end there. Proxima Centauri emits almost the same amount of energy from its star as Earth does from the Sun. Could this mean there's water on its surface? Perhaps life as we know it could exist beyond our solar system. As we venture farther into space, we encounter a whole new world of exoplanets. Planets that orbit stars other than the Sun. With 200 billion stars in the Milky Way galaxy alone, the opportunities for exoplanets are endless. Some even wander through space untethered to any star, like rogue pioneers among them. Proxima Centauri B stands out as a truly amazing and puzzling planet, with a year lasting just 11.2 Earth days. Its distance from its star is much closer than Earth's distance from the Sun. This means one side of the planet is perpetually bathed in light, while the other remains in eternal darkness. Now, let's examine Proxima Centauri, the star around which Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system, which includes Alpha Centauri A and B, 2G and K-type stars that appear as one in the constellation Centaurus and are the third brightest stars in our night sky. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf or M-type star located 4.24 light-years from the other two stars, making it the closest star to our solar system. Proxima Centauri means the closest star in Latin and was discovered in 1951 by Scottish astronomer Robert Thorburn. Despite being the closest star to us, Proxima Centauri remains invisible to the naked eye due to its apparent magnitude of plus 11.13, which is beyond the limit of human vision. However, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarf stars like Proxima Centauri are among the most efficient in terms of energy production. While they may not emit much light, the convection process at their cores keeps them shining for trillions of years. In fact, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf like Proxima Centauri is still debated. For one, it's a flare star, meaning it undergoes regular and unpredictable eruptions. As a low-mass star, its habitable zone would be much closer to it than the Sun's, likely between 0.23 and 54 cents. Yet, even this zone may not be as hospitable as it seems. Proxima B may not have a stable atmosphere, which is critical for maintaining conditions suitable for liquid water on its surface. Without this stability, life would be vulnerable to space weather, making it extremely difficult for life to thrive. So while Proxima B may appear Earth-like on the surface, it's far from being capable of supporting life. Still, many scientists continue to hold hope. One tool that has captured the attention of astronomers is the James Webb Telescope. After several delays, the telescope was finally launched in 2018 and will help determine if there is life on Proxima B. However, as with everything in science, things are never as clear-cut as they seem. Several modifications were necessary to ensure the James Webb Telescope could deliver accurate images. As Abby Wind, a theoretical physicist at Harvard, explains, if a planet like Proxima B absorbs light from its star, it can also remit that light as infrared radiation. The James Webb Telescope was specifically designed to detect infrared light, allowing it to capture images of this radiation on the planet's surface and look for patterns that could confirm whether the planet has water or an atmosphere. But what if the planet's atmosphere is not suitable for life? The presence of an atmosphere doesn't guarantee life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere far denser than Earth's, resulting in extreme heat that would make life impossible. The mission to uncover the truth about Proxima B is not without its challenges. While the James Webb Telescope holds promise, there are many variables to consider. With costs mounting, space researchers are feeling the pressure to find ways to study planets like Proxima B. The stakes are high, but the rewards are even greater. The chance to catch a glimpse into the unknown and uncover the secrets of a planet that could harbor life is a goal any serious scientist would pursue. But could we ever travel to Proxima B? It's the closest exoplanet to us, which makes it an exciting prospect. It's almost like exploring our own backyard. Even more intriguing is the fact that it's nearly the same size as Earth. Its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it a viable target for our search for life beyond Earth. At just 4.2 light-years away, it's an ideal candidate for interstellar missions. Now consider the possibility of exploring this Earth-like exoplanet. However, we can't go there just yet, but it's certainly on the radar for future missions as technology progresses, making space travel more accessible. Proxima B remains one of the most exciting possibilities in the field of space exploration. However, it's no simple task to get there. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. That said, a proposal has been made involving solar sails, ultra-thin sails that could be used to accelerate a spacecraft toward the Alpha Centauri system and Proxima along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. With anticipated speeds of 10% to 20% of the speed of light, the journey to the Alpha Centauri system could be reduced to just 20 years. The discovery of Proxima B has reignited humanity's interest in space exploration. It has given us a renewed sense of hope that we are not alone in the universe. The James Webb Telescope is a marvel of modern technology, capable of taking us all the way back to the very beginning of the universe, 13.7 billion years ago. This is the carefully preserved secret. The farther an object is, the longer it takes for light to reach us. This means the James Webb Telescope can observe objects in the universe farther away than any other telescope before it. Additionally, it can detect these objects in longer wavelengths of infrared light, allowing us to see more distant stars with greater clarity than ever before. Here's something even cooler. This incredible technology can provide insights into the possibility of life on other planets like Proxima B. However, like everything, there are some notable limitations. The presence of an atmosphere doesn't necessarily guarantee life. Proxima B could be like Venus with a thick toxic atmosphere. But get this, the James Webb Telescope can detect such conditions if they reach a brightness of just 5% of the planet's dayside. While 5% might not seem like much, it's quite significant when dealing with a star that's generally dimmer than our Sun. If Proxima B has intelligent life, they might be using brilliant orbital mirrors to reflect sunlight from the day side of the planet to the night side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being massive gas giants, while others resemble our own Earth. One type of exoplanet that has caught the attention of space experts is the gas giant. These planets are similar in structure to Jupiter and Saturn but are much larger. Some of these behemoths have been dubbed superjupiters, surpassing even the largest planet in our solar system. But that's not all. There are also hot Jupiters, gas giants that orbit incredibly close to their host star. They exist in a blistering environment with temperatures high enough to melt metal. Imagine being able to observe such a planet up close, with its raging storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are hot Neptunes and mini Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, making their atmospheres difficult to study from afar. Furthermore, we shouldn't forget about terrestrial exoplanets, those that resemble our own Earth. These planets come in various sizes, from smaller than Earth to twice its size. There are also super-Earths, which have masses greater than twice that of our planet, yet are lighter than Neptune. One of the most intriguing exoplanets discovered recently is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a temperate terrestrial exoplanet, meaning it could potentially support liquid water. Scientists believe it may be habitable, especially considering its proximity to its host star. Proxima B's potential to support life has made it the subject of intense study. Although it sits within the habitable zone of its parent star, many uncertainties still surround its atmosphere and overall habitability. One of the major challenges for Proxima B is the intense stellar flares that Proxima Centauri emits. These flares could strip away the planet's atmosphere over time, making it harder for life to thrive, much like the early stages of Mars history. The magnetic field of Proxima B would play a crucial role in protecting the atmosphere, but without that shield, the planet could face extreme conditions that prevent the development of life. Despite these obstacles, scientists remain hopeful. Advances in technology, such as the James Webb Telescope, will continue to offer new insights into Proxima B's atmosphere and whether it might contain the necessary conditions for life, like liquid water. The telescope is capable of analyzing the planet's atmospheric composition, searching for key chemicals that could signal biological activity, such as oxygen, methane, or carbon dioxide. Even if Proxima B is inhabitable, the discovery of so many potentially Earth-like exoplanets in the habitable zones of distant stars opens up new possibilities for finding life beyond Earth. The search for exoplanets is one of the most exciting areas of research today. The vast number of stars and planets in our galaxy suggests that life may be more common than we once thought. Even though we are far from reaching these distant worlds, the pursuit of knowledge about our universe is a journey worth undertaking. For now, Proxima B remains one of our closest, most intriguing targets in the search for life beyond Earth. As technology continues to evolve and as we learn more about the complex factors that make a planet habitable, we move one step closer to answering one of humanity's oldest questions. Are we alone in the universe? The exploration of Proxima B and other exoplanets is just the beginning, and the next few decades could hold groundbreaking discoveries that will shape our understanding of life in the cosmos. As humanity looks toward the stars, the discovery of exoplanets like Proxima B offers a glimpse into the future of space exploration and the search for life beyond Earth. The study of exoplanets, planets orbiting stars outside of our solar system, has become one of the most exciting fields in modern astronomy. With the development of advanced telescopes and new technologies, we are now able to discover and study planets that were once beyond our reach. As we refine our tools and methods, more and more planets are being found in the habitable zone, the region around a star where conditions may be right for liquid water to exist on the surface, an essential ingredient for life as we know it. In recent years, we have learned that the universe is teeming with a variety of planets, each with its own unique characteristics. Some of these planets are Earth-like, with conditions that may support life. Others, like the gas giants and ice giants, offer a vastly different environment. The diversity of planets within the galaxy suggests that we are just beginning to scratch the surface of what is out there. As new techniques in space exploration advance, scientists have begun to hone in on particular targets like Proxima B to understand whether they could be home to life. One fascinating aspect of Proxima B is its potential to harbor liquid water. While many factors influence whether water can exist on a planet's surface, including its atmospheric pressure, temperature, and the amount of radiation from its star, Proxima B is within the habitable zone of its star, Proxima Centauri. This proximity means the planet could have liquid water under the right conditions. However, the ongoing debate about its atmosphere and the potential for water continues, as the star itself is known to produce intense flares that could disrupt a planet's atmosphere. Scientists are working to determine whether Proxima B has an atmosphere thick enough to withstand these space weather events and maintain the necessary conditions for life. In addition to the challenges posed by Proxima Centauri's flares, there are other questions surrounding the planet's habitability. One such question is the planet's rotation. Proxima B is thought to be tidally locked, meaning one side of the planet always faces its star, while the other remains in perpetual darkness. This could create extreme temperature differences across the planet, with one side potentially being too hot to support life, while the other may be too cold. The potential for a habitable zone between these extremes, such as a twilight region where temperatures are more moderate, adds to the intrigue surrounding Proxima B's habitability. There are also questions about the planet's size and composition. Proxima B is roughly the size of Earth, making it a prime candidate for study. A planet of this size has the potential to host a variety of environments, from vast oceans to towering mountains, forests, and deserts. Its mass is similar to Earth's, which suggests that it could have a similar internal structure and geological activity. This could mean that Proxima B, like Earth, may have tectonic plates and volcanic activity, two factors that are essential for maintaining a dynamic atmosphere and for recycling carbon, an important element for life. The search for life on Proxima B also involves studying its star, Proxima Centauri. As a red dwarf star, Proxima Centauri is cooler and dimmer than our Sun, which makes it a unique target for study. These stars have a much longer lifespan than more massive stars, providing a more stable environment for planets to evolve over billions of years. While red dwarfs are often considered hostile to life due to their frequent flare-ups, some scientists believe that Proxima B may have developed mechanisms to survive these extreme conditions. There is also the possibility that Proxima B's magnetic field could provide some protection, much like Earth's magnetic field shields us from the harmful effects of solar radiation. Looking beyond Proxima B, astronomers are also interested in discovering other exoplanets that could share similar characteristics. Advances in technology, such as the upcoming James Webb Space Telescope, will allow scientists to examine the atmospheres of distant planets in more detail. This will help us identify potentially habitable planets with the right chemical signatures for life. The detection of biosignatures, like oxygen or methane in a planet's atmosphere, could be the key to unlocking the mystery of extraterrestrial life. Moreover, the search for life on exoplanets is not limited to just finding Earth-like planets. The discovery of a wide variety of exoplanet types, including super-Earths, gas giants, and ice giants, provides new avenues for research. These planets may not be habitable themselves, but their moons could be. Many of the gas giants discovered so far have large moons, some of which are thought to have subsurface oceans, much like Jupiter's moon Europa or Saturn's moon Enceladus. These moons could be even more promising targets for life than the planets themselves. In the long term, the search for life beyond Earth could lead to a deeper understanding of the origins of life itself. If we find life on a planet like Proxima B or one of its moons, it could provide crucial insights into how life may have originated on Earth. Even if we don't find direct evidence of life, the study of these planets will help us refine our understanding of the conditions necessary for life to thrive. As the search for life on exoplanets progresses, the prospect of discovering other Earth-like worlds remains one of the most exciting and important goals in science. The journey to uncover the secrets of planets like Proxima B is just beginning, and with each new discovery, we come closer to answering one of humanity's most profound questions. Are we alone in the universe?